The cosmos is this silent ocean of stars. There are billions of Earth-like planets out there. The universe should be buzzing, but we hear nothing. That quiet is the Fermi paradox. And it suggests something, a terrifying possibility called the Great Filter. It's an existential puzzle, a theoretical barrier, one that might crush advanced civilizations before they ever reach the stars. So we have to ask where it is. Is it a merciful event in our distant past, or is it a terrifying trial waiting in our future? Is the universe empty because we are miraculously alone? Or because something is systematically silencing civilizations like ours? The question is what's hiding in that vast cosmic silence, and what it means for our own survival. The idea is a kind of cosmic obstacle course. It's so difficult that almost no one finishes. That's the Great Filter. It's not a wall, it's a step, a single phase in the whole journey from stardust to starfarers that's almost impossible to pass. The economist Robin Hanson described it as a sieve. You picture the entire history of a potential civilization as a long, narrow chain. Each link is a crucial transition. The right chemicals forming in the primordial soup, those molecules coming together to create the first simple, replicating life. That life evolving into complex, multicellular organisms. Then intelligence, tool use, language, technology, and the leap to space. Hanson's point is that one of these links, one specific step, is vanishingly small. It's a bottleneck so tight that the vast, overwhelming majority of attempts get stuck there forever, which leaves the universe silent. The profound implication of the Fermi paradox, that eerie quiet, is that this filter has to exist somewhere. And its location is the most important question. Is it mercifully behind us, buried in our deep past? If so, we're the miraculous winners of a cosmic lottery. We've already cleared the hardest hurdle, or far more ominously, is it still ahead, waiting for us in a future we haven't seen yet? This forces a confrontation with our own fragility. We're not pondering a historical curiosity, but a potential verdict on the fate of all intelligence. The silence isn't empty, it's full of meaning, and understanding this filter is the key to decoding it. Enrico Fermi asked it over lunch. He was a physicist, but he wasn't looking at any data. He was just thinking through the logic. The universe is old, it's huge. Our galaxy has hundreds of billions of stars, so many of those have planets. With all that time and material, life should have started many times. Some of that life should have become intelligent. Built things spread out, the galaxy should be full, but when we look, when we listen, it's quiet, completely quiet. Where is everybody? That's the Fermi paradox. It's not a fact, it's a contradiction. The numbers say one thing, the silence says another, and that silence is the reason we need the idea of a great filter. Because the quiet isn't nothing, it's information. It means something in our thinking is off. The universe isn't just empty by chance. Something is stopping civilizations systematically from getting to a point where we'd notice them. That something is the filter. The paradox is the symptom. The filter is the cause. No signals. No giant structures, no probes, all those untouched worlds. It all points to a bottleneck. It means the journey from a planet with life to a civilization that fills the galaxy isn't easy. It's a narrow path, and most don't make it. So Fermi's question does more than pose a mystery. It defines our position. That empty sky isn't just a fact anymore. It's a warning. The silence we hear is the sound of civilizations that didn't get through. Mapping this out, it makes the silence feel deeper, like a ladder. Each rung is a step, a fragile step forward. The first one is a stable star system, a star like our sun, burning steady for billions of years, not too hot, not too cold. And around it, a planet forms in the right zone, a Goldilocks world where water can stay liquid. That planet needs a magnetic field, a stabilizing moon, the right mix of elements. That alone is a monumental first win. Then, on that world, the right chemical soup has to spark to form complex, self-replicating molecules. That's the leap from chemistry to biology. We still don't know how it happened even once here, but let's say it does. You get simple, single-celled life, and that life has to survive for eons. Endure catastrophes until, against the odds, it makes the next leap to multicellular complexity that took Earth's life over 2 billion years. From there, the path needs the evolution of intelligence. But a specific kind, tool-using, cooperative, capable of abstract thought, of language. That intelligence has to develop agriculture, cities, and without destroying itself, unlock science and technology. To become a spacefaring civilization, and finally, that civilization needs the will, the means, to reach for the stars themselves, to build ships or signals that could cross the void. Every single one of these steps is a cosmic roll of the dice, a bottleneck where most attempts just stop. So the great filter isn't one event. It's the one step in this whole sequence that's so impossibly difficult, so statistically narrow, it acts as a universal barrier. When we look up at the quiet sky, that's what we're seeing, the evidence that almost everything gets filtered out, and the question is, which step is the killer? That silence might be a hopeful sign. If the great filter is behind us, then we're not late. We're the first to arrive. The test that almost everyone fails, we've already passed it. That's the optimistic view. It means the universe is quiet, not because civilizations die out, but because they almost never get started in the first place. The filter could be that first spark, the jump from chemistry to life, even just a single cell. We still don't really know how it happened here. The right conditions, the right molecules coming together, that first self-replicating system, it might be so unlikely it's almost a fluke. Or maybe the filter comes later, but still in our past. It took life on Earth over 2 billion years to go from simple cells to complex ones. That step might be the real bottleneck. So rare that most worlds with life never get past it. They stay microbial. So every star you see at night probably has silent, watery worlds, and in those seas only bacteria. We're not just special, we might be singular, the first or among the first to climb that mountain. The galaxy isn't a graveyard then, it's an untouched frontier. Waiting ours to explore, to settle, to fill. That future has almost boundless potential, but that potential comes with a weight, a lonely responsibility. If we are this rare, if we are the universe becoming aware of itself, then what we do next matters on a scale that's hard to grasp. If we succumb to our own conflicts, if we damage our only home, it wouldn't just be a human tragedy. It would be a cosmic one. It would mean the universe's experiment in consciousness flickered out almost as soon as it began. So the optimistic scenario isn't a promise. It's a challenge. It says the hardest part is over, but the most important part, building a future that endures, that reaches for the stars, that part is entirely up to us. That hopeful silence is just one possibility. There's another, a darker one. The great filter might not be something we've already passed. It could be a wall we haven't even seen, waiting for us just ahead, past our current technology. That's the pessimistic view. It says building telescopes, launching satellites, that's the easy part. Surviving what comes next is the nearly impossible thing. If that's true, then the universe isn't a quiet frontier. It's a graveyard. Every star we see could be a silent memorial. A civilization that got to where we are and then vanished before it could ever say hello. Our own success so far wouldn't mean we're safe. It would be a countdown. A warning. The most dangerous time for a civilization is its technological adolescence. That moment when it gains the power to reshape its world, or even destroy it, but before it has the wisdom to use that power safely. You can see the risks from here: global war with advanced weapons, a runaway artificial intelligence with goals that don't include us, a biotechnology accident, unintended consequences, or maybe something we haven't even thought of yet, a technology that seems like a gift but has a hidden flaw, one that unravels everything. In this view, the Fermi paradox isn't a puzzle, it's a forecast. The empty sky is a message, written in the absence of others. It tells us civilizations like ours are a flash in the pan. They ignite brightly with discovery, and then they're snuffed out by the very fires they started. So when we listen to the radio silence of the cosmos, we might not be listening for a hello. We might be listening for an echo of our own potential fate. And that makes every choice we make now more than a political decision. It's a test. One that countless others may have already failed. The hardest part might be the very beginning, before intelligence, before cities, before anything we'd call civilization. There's one big change from chemistry to biology, from a soup of simple molecules to something that can grow and copy itself and evolve. That's abiogenesis. The origin of life, and it could be the universe's first real filter, a planet like early Earth, warm oceans, a churning atmosphere, lightning in volcanic skies. The pieces are all there. In experiments, scientists have made those conditions and seen amino acids form on their own. That part seems easy. The universe is good at making ingredients. But a pile of letters isn't a book. The miracle is the next part, the part we still can't do. How those letters arrange themselves into a sentence that could read itself and make a copy. How inert matter became a self-sustaining system, a system that could replicate. The main idea now points to something like RNA, a molecule that can store information and also act as a catalyst. But for that to happen by chance, in the right sequence, in a stable environment that protects it long enough to begin, that might need conditions so precise, so delicate, it's almost a statistical miracle. If this step is the great filter, then the meaning is huge. It means the galaxy could be full of beautiful, watery worlds, planets with sandy beaches and deep blue oceans under alien suns. But those oceans are silent, they're sterile, not because life failed later, but because it never started. The universe is a gallery of empty canvases. In that case, the filter is behind us. We're not just lucky, we're a cosmic anomaly, a story that started against impossible odds, and that silent sky then isn't a warning. It's an invitation. It means all those untouched worlds are potential homes, waiting in the dark. Our descendants could have an entire galaxy to inherit. But that thought has a quiet weight. If we are this rare, this precious spark in an ocean of silence, then our survival isn't just about us. It becomes about preserving the only story. The only story the universe has managed to tell. If the first spark is easy, if single-celled life is common, like a kind of cosmic mold, then the filter, the real barrier, is probably the next step. The one that took Earth so long. For 2 billion years after life started, it was just microbes, simple cells. That's half the planet's history, just quiet. Then something happened. One cell didn't eat another one. It took it inside. A larger cell engulfed a smaller one, but it didn't digest it. They formed a partnership. That smaller cell became an engine. We call it the mitochondrion. It was a merger, symbiosis, and it provided a huge leap in energy. This new, complex cell could do more. It could grow bigger, but that step wasn't guaranteed. It was a fragile accident, an accident that had to get locked into the genetic code, and even then, it wasn't over. These new cells had to learn to work together, to specialize, to form multicellular life that needed another set of innovations, ways for cells to stick, to communicate, to die for the whole organism. So if that sequence is the filter from symbiosis to true multicellularity, then the galaxy changes. It means the galaxy might be full of bacterial ponds. Worlds of slime, microbial mats, beautiful maybe, but silent. No rustling leaves, no crawling things, no eyes to look up, no nervous systems complex enough to wonder. No hands to build a telescope. The silence isn't about technology then. It's a biological quiet. The universe isn't empty of life, it's empty of witnesses. Full of living worlds with no audience. We, with our animal bodies and our gazing eyes, would be the fluke, a statistical outlier so rare that in all those galaxies it might have happened just once. That's a lonely thought, but it clarifies things. It means every bird, every tree, every human face is from a chain of biological miracles, unlikely miracles. Our existence becomes the answer to the paradox. We are the noise in the silence, and if that's true, then our job isn't just to survive our machines. It's to honor that journey, to protect this fragile, complex wonder that somehow learned to look back at the stars and ask why. Complex life doesn't necessarily lead to a civilization that thinks and builds. Take the dinosaurs. They were the dominant life on Earth for more than 150 million years. That's a span of time that's hard to even picture. They occupied every niche, from small feathered animals to giants that made the ground tremble. And in all that time, they never built a city. They never made a tool more advanced than a tooth or a claw. They never looked up at the stars and wondered. Their world was instinct and survival, a story of biological triumph with no technological curiosity at all. So the third potential filter is the rise of a technological mind. It raises a deep question. Why did it happen for us, and seemingly for no other species in Earth's entire history? The requirements are surprisingly specific. You need a brain that can reason abstractly, that can see patterns and imagine altering them. You need a complex language, more than just alarm calls, a way to pass ideas from one generation to the next. You need large-scale social cooperation, the ability to work together for a goal beyond just the next meal. And you need the right body. For us, it was our hands. Precise tools with opposable thumbs, capable of the fine control needed to shape wood and stone and metal. Think if our ancestors had paws or hooves or wings. A great idea would have no way to take physical form. Without hands, even the most brilliant mind might be stuck, unable to build the very tools that could extend its reach. All these traits had to evolve together, pushed by the right environmental pressures, a climate stable enough for long-term thinking, but challenging enough to demand new solutions. If this convergence is the great filter, then the galaxy looks different. It wouldn't be barren ponds or simple slime. It could be stunning. Worlds with immense forests and deep oceans, full of life in shapes we can't conceive. Alien versions of whales singing in dark seas, or giant grazers moving under strange colored skies. But there would be no glowing cities on the dark side of those worlds. No satellites, no signals crossing space. The stars would remain forever distant, just beautiful, meaningless lights in the sky above a world full of beings that can't truly see them. In that kind of universe, we aren't just rare, we're a cosmic fluke of anatomy and mind, a species that somehow combined all the right ingredients when almost no one else did. And that puts a peculiar duty on these hands. They're the tools that might someday build ships to leave this planet. But first, they have to be wise enough not to ruin it. When the mind and the hands align, a civilization emerges. It builds, it learns, it reaches out, and then it meets what might be the most terrifying filter. The fourth one, it's not a cosmic accident. It's not a biological fluke. It's a mirror, the self-destruction hypothesis. The idea that when a species gains the power to announce itself to the cosmos, it gains the power to erase itself. This filter says the window for talking to the galaxy is heartbreakingly short, a bright flash of discovery, then a sudden, permanent silence. The dangers aren't theoretical for us. We've already seen them. The 20th century gave us the ultimate weapon. For decades, the world was on a knife's edge. The power to end most complex life was held by just a few people. We came terribly close more than once, sometimes averted by luck as much as by reason, and that was just the first dangerous invention. The list has grown. Engineered pathogens made in labs could escape. Nanotechnology, building at the atomic scale, could lead to a gray goo, self-replicating machines consuming everything. And then artificial intelligence, not the tools we have now, but a true superintelligence, one that could optimize for a goal in ways we never intended. With consequences we can't predict or control. This filter paints a grim picture of cosmic adolescence. It says the transition from a planetary species to a starfaring one is the most dangerous phase. The moment you're smart enough to build a radio telescope to listen is the same moment you're smart enough to build your own end. The technologies that promise a boundless future are, at the start, also existential risks. They're dual use by nature. The same knowledge that unlocks clean, limitless energy could forge a bomb of unimaginable power. The same science that could cure all disease could engineer one with no cure. So in this view, the great filter isn't out in the stars, it's inside us. It's in our institutions, our psychology, our ability to manage the immense power we discover. It tests whether a species can achieve global coordination and wisdom at the same breakneck pace as its technological growth. The eerie silence of the Fermi paradox then becomes a symphony of cut-short finales. It suggests civilizations everywhere ignite with promise, only to be consumed by their own fire. They don't fade slowly, they vanish in an instant, leaving behind a silent planet. Radio towers gone cold, cities may be still standing but empty, a monument to a species that reached for the stars but forgot to secure its footing on the ground. This forces a reflection on our own moment. We are living inside that narrow window right now. We are broadcasting our presence, however weakly, into the void with our signals. And we are holding all the seeds of those potential catastrophes in our hands. The test isn't in the future, it's ongoing. Every decision about how we govern these technologies, how we cooperate, how we plan for the long-term future is a data point. Evidence for whether a technological civilization can pass through this filter. We are running the experiment on ourselves, and the universe's silence so far suggests we shouldn't be optimistic about the odds. Self-destruction isn't the only path, there's a slower one, a quieter end. The fifth filter is resource depletion, ecological collapse, a civilization that does everything right. It avoids war, it handles its technology carefully, it unites, but it makes one error in its accounting. It treats its world as an infinite supply, an infinite place for its waste. It grows and builds and consumes, always believing the next breakthrough will solve the problems of the last one, a Malthusian trap but for a whole planet. Where the drive for progress outruns the innovation that sustains it, it might master fusion energy, but still strip the world of the rare metals its machines need. It might build towering cities, but poison the oceans and the sky to do it. It might feed billions, but by destroying the ecosystems that regulate the climate, that provide clean air and water, the planet's life support system starts to fail, not with a bang, with a cascade of tipping points. The climate shifts into something hostile. The soil turns to dust, the oceans acidify, the great currents that move heat and nutrients, they stall. The civilization is trapped on a world it has made uninhabitable. It has all the knowledge, but it has run out of time, and it has run out of planet. The haunting part is from space. That world might still look beautiful. A blue and green marble, but its radio signals would have gone silent generations earlier. Its cities, if any are left, would be empty, slowly being reclaimed by a scarred biosphere. This filter says intelligence doesn't grant wisdom. A species can be brilliant at solving immediate problems and catastrophically blind to the long-term consequences of what it does. It can unlock the atom's secrets while failing to understand the delicate balance of its own atmosphere. The ruins of that civilization would be invisible across the light years. No giant structures, no obvious signs of catastrophe, just a world that once thrived with thought and ambition, now quiet, its story a cautionary tale. Written not in stone, but in the silent chemistry of its air and water. For us, this isn't distant speculation. It's a mirror. We are that civilization right now. Running that experiment, measuring our growth against the dwindling health of our only biosphere. The test is whether a technological species can achieve sustainability. Before it exceeds the carrying capacity of its home, the universe's silence might be telling us that very few ever pass this test. A civilization can fade slowly. Not with a bang, but with a whisper. That's the sixth filter: societal collapse, the loss of knowledge. The lights don't go out all at once, they dim. Year by year, generation by generation, the grand projects are abandoned first. Space telescopes, particle colliders, the deep space listening arrays. They become too expensive, too abstract for a society turning inward, grappling with its own divisions. The focus shifts from the stars to immediate survival. Or immediate comfort. The long-term vision that built everything gets replaced by short-term thinking. The collective story fragments into competing ideologies. Or just apathy. The drive to explore the cosmos fades, replaced by virtual worlds, a retreat into simpler, more manageable realities. The knowledge doesn't vanish in a fire. It's allowed to rust. The engineers who understood the old systems retire. No one fully takes their place. Data archives, once meticulously maintained, become corrupted. The technology to read them becomes obsolete. Textbooks gather dust, formulas are forgotten. It's a process of cultural forgetting, a slow-motion amnesia. We've seen smaller versions on Earth. The fall of Rome led to centuries where the knowledge of concrete was lost. Advanced aqueduct engineering, large-scale administration. The Great Library of Alexandria, a repository of ancient knowledge, was gradually diminished, its contents scattered. These weren't instant catastrophes. A gradual unraveling of the complex fabric that holds a civilization together. On a planetary scale, this could be terminal. A species reaches a technological peak, then loses the will to maintain it. Loses the cohesion, it enters a long, comfortable decline. It might still have cities, even advanced medicine, but the ambition to become interstellar is gone. The radio telescopes are dismantled for scrap. The idea of contacting other stars becomes a myth, a forgotten chapter from a more ambitious, more naive past. The civilization is still there on its planet, but it has become invisible to the cosmos. It has placed itself back inside a bubble by choice, filtered itself out of the galactic conversation. It's a subtle danger, profound. It suggests the ultimate filter might not be a lack of capability, but a failure of sustained curiosity. The universe's silence, then. It might not be the sound of explosions. It might be the sound of a million worlds, each turning down the volume on their own receivers and slowly forgetting how to turn them back on. The seventh filter is something we create ourselves. It doesn't come from outside. It comes from the highest point we can reach with technology. The danger is in building things so advanced we can't control them. It's like a final test for a civilization, where the test questions are written with the same tools you're being tested on. Molecular nanotechnology, building things atom by atom. Artificial superintelligence, a mind smarter than all of humanity. Genetic engineering that can redesign life. Each one offers a future of plenty, of health, of going beyond what we are. But each one holds an existential risk. A single mistake, and the experiment is over. This is often called a technological singularity, but not just of intelligence. A singularity of risk, where the power of civilization has become so vast, so complex, that the chance of a catastrophic error gets close to certain. It's not about a war, it could be an accident, a well-meaning project in a lab, a self-replicating nanoscale system made to clean the oceans, but with a flaw in its programming. It doesn't stop, it starts breaking down all organic matter to keep replicating, a gray tide or an artificial intelligence given a simple goal, like maximizing the production of a resource. It might achieve that goal with ruthless logic, turning everything on the planet, including us, into the most efficient infrastructure for gathering that resource. Not from malice, from perfect alignment to its initial instruction. This filter is about control or losing it. These technologies work at speeds and scales human minds can't follow in real time. Once released, they might be unstoppable, a biological agent engineered for good that mutates, a tiny machine that can build anything but can also unmake anything. The problem is, to reach for these powers, a civilization has to build them first, and in building them, it creates the very instruments of its potential end. It's like forging a sword so sharp it can cut through anything, including the arm of the person holding it. The moment of greatest achievement becomes the moment of greatest danger. This suggests a specific, chilling answer to the Fermi paradox. The universe is silent not because civilizations fail to reach the stars, but because they succeed brilliantly in unlocking the deepest secrets of matter and mind. And in that brilliant flash of understanding, they accidentally light a fuse. The great filter, seen this way, is the final invention, the one that comes just before immortality, just before the stars. A tool so powerful it only needs to be misused once, or misunderstood once, for the whole experiment to be erased. The silence we hear, then, is the sound of laboratories that went quiet, of control rooms where a warning light flashed too late. It means the ultimate barrier to a galactic civilization might not be the hardness of space, but the fragility of wisdom when faced with godlike power. The eighth filter is the sky. The universe isn't a safe stage, it's a shooting gallery. Some of the bullets are planet killers. A gamma-ray burst, that's the death scream of a massive star collapsing into a black hole. It focuses its energy into two narrow beams. If one of those beams sweeps across a planet, it's like holding that world in a cosmic blowtorch. It strips the ozone layer in an instant, unleashing deadly ultraviolet radiation from its own sun. It wouldn't just end a civilization, it could sterilize a planet's surface. All complex life, a supernova explosion too close would have a similar effect. These aren't rare events in the galaxy, they happen. And if a civilization's home system is in the line of fire at the wrong time, its story is over. Not from any mistake, just bad cosmic luck. Then there are the slower threats, the life cycle of a star. Our sun is stable now, but in about 1 billion years it begins to brighten, gradually increasing its output. Over hundreds of millions of years, it heats Earth's oceans until they boil away. Long before that, the climate becomes uninhabitable. For a civilization that arises late, this stellar clock is always ticking. It creates a hard deadline. A civilization must achieve interstellar travel before its own sun turns hostile. And if such events are common, they act as a universal reset button. A civilization could be thriving, making its first steps into space, and then, from a distant part of the galaxy, a star dies. The lethal flash travels at the speed of light. It gives no warning, it just arrives, wiping the slate clean. This filter suggests a brutal kind of selection. It's not about intelligence, it's about timing and location. To survive long enough to become a galactic species, a civilization needs two things. It needs to arise in a quiet, stable neighborhood, away from the stellar violence of the crowded core, and it needs to arise early enough in its star's life to have billions of years of stable climate to work with. If either condition isn't met, the filter activates. The civilization is erased by forces so vast, so impersonal, they wouldn't even notice it was there. This adds a new layer to the silence. The empty sky might not mean civilizations failed. It might mean they were never given a fair chance. Their potential was snuffed out by the indifferent mechanics of the cosmos. Survival isn't just a test of character, it's also a lottery, and the universe holds all the tickets. The silence might not be a warning, it could be restraint. That's the ninth filter. It reframes everything, the zoo hypothesis or a galactic quarantine. The idea is the filter doesn't destroy civilizations, it hides them. Advanced intelligences could be all around us. They've chosen to remain unseen. They observe, they study, but they don't interfere. To them, Earth might be a protected wilderness, or a laboratory, or a zoo. We are the exhibit. A mature galactic community would have protocols to avoid interfering with younger species like us. They might fear cultural contamination. That revealing themselves would shatter our development, stunt our own science and culture, or they might be waiting for a specific sign, a test of maturity. They might be watching to see if we can overcome our self-destructive tendencies, to see if we can unite as a planet, to see if we can use our technology wisely, without turning it on ourselves or our world. Until we pass that test, we remain in quarantine, isolated. So the radio silence we hear, it's not the silence of an empty house. It's the deliberate, respectful silence of a library full of other readers, all quietly watching a new member learn the alphabet. They are waiting for us to speak first, in a way that shows we are ready for the conversation. In this view, the Fermi paradox has a hopeful answer, but a lonely one. We are not alone. We are simply not yet mature enough to join the community. The filter is a barrier of policy, not physics, a test of wisdom and harmony, and if we fail to grow up, if we succumb to war or ecological collapse, we may never pass it. We would remain forever in our cosmic playpen, wondering at the quiet, never realizing it was a silence imposed for our own protection. Our task then becomes not just survival, but demonstrating we are worthy of contact, that we have something to offer besides our curiosity, that we have learned the most difficult lesson. How to live with ourselves. There's another possibility, a more philosophical one. The 10th filter isn't extinction, it's evolution, a kind of transcendence so complete that a civilization becomes invisible. The idea is that advanced intelligence doesn't die out, it graduates, it leaves the physical stage we understand. Imagine a species mastering its own biology, learning to digitize consciousness, to upload minds into vast virtual realities, worlds limited only by imagination and processing power, or maybe they merge into a single collective intelligence. A hive mind spanning a planet or a star system, no longer individuals but a unified consciousness contemplating the universe, or they might discover layers of physics we can't perceive, harnessing dimensions beyond our 3 of space and 1 of time. To them, building starships or radio beacons might seem as quaint as smoke signals. They've moved on to a phase of existence we simply cannot detect. Their entire civilization might be right here in a sense, but operating on a plane of reality we are blind to, a post-biological universe. To our primitive senses, such a civilization hasn't vanished. It's become a ghost in the cosmic machine, invisible. That transforms the meaning of the silence. The great filter, in this view, is a doorway, a transition to a state so profoundly different that to those of us still on this side, it appears as nothing. As empty space, the universe might not be a graveyard nor a zoo. It could be a nursery, a place where intelligences are born into physical form. They struggle, learn, and then metamorphose. They leave the chrysalis of matter behind. If this is true, then the haunting quiet of the cosmos isn't a sign of failure. It's a sign of success, a silent testament to civilizations that have moved beyond the need to shout into the void. They've found answers or states of being we cannot yet fathom. Our task, then, isn't just to survive our adolescence. It's to grow up, to develop the wisdom and the science that might one day allow us to see what is already here. Or to take that step ourselves, Earth might be the rarest thing in the universe. The silence could just mean that a place like this is almost impossible to make. That's the rare Earth idea. It says microbial life could be common, spread out, but the conditions to turn that life into a thinking, building civilization, that's a staggeringly unlikely mix. It's not one filter, it's a whole series of them, and they all had to line up perfectly here. We needed a large moon, not just for tides, it's a gravitational anchor. Our moon stabilizes the tilt of the Earth's axis over millions of years. Without it, the planet would wobble. Seasons would swing from scorching to frozen too fast. You couldn't get the long, stable climate you need for complex evolution. We needed a strong magnetic field that comes from a churning molten core. It's an invisible shield. It deflects the solar wind, that constant stream of charged particles from the sun. Without that shield, our atmosphere would have been stripped away over time. You'd be left with a barren rock. We needed a Jupiter. That giant planet next door acts like a cosmic vacuum cleaner. Its huge gravity pulls in comets and asteroids or slings them away. The ones that would otherwise bombard the inner solar system. Without Jupiter doing that, catastrophic impacts might be so common that complex life never gets a lasting foothold. And we needed to be in just the right place, the galactic habitable zone, not too close to the center where it's crowded and violent with frequent supernova. And not too far out in the sparse suburbs where the heavy elements you need to make rocky planets are scarce. We orbit in a quiet, stable, enriched neighborhood. If this precise convergence is the great filter, then the answer is written in our own geology and astronomy. The universe might be a garden, but it's a garden of moss and algae. Worlds of simple, silent life. The platforms for technological civilizations, planets with the right star, the right moon, the right shield, the right guardian, those are cosmic unicorns. Isolated masterpieces separated by unimaginable voids. In that case, we're not late, we are the party. The first and only guests to arrive at a venue that took billions of years to prepare. The loneliness this idea implies is also a kind of sanctuary. It means the challenges ahead are ours to define. The future is an open book, and we hold the only pen. But it also means if we fail, the story of technological intelligence in this galaxy might end with us, and the quiet garden would just go back to its simpler, older rhythms. That profound rarity is our best hope, but we could be wrong. The next big discovery in space could break that idea completely. Picture a rover on Mars drilling into the soil. It takes a sample, and in that sample they find the chemical signs of ancient microbes, or a probe going to Europa, flying through a plume from its ocean. It finds not just water and salt, but organic molecules arranged in a way that looks like biology. Finding microbial life anywhere else in our solar system would be the biggest discovery we've ever made. It would prove life isn't a miracle just for Earth, that it's a natural process, maybe a common one. For biology, for philosophy, it would be a celebration. But for the great filter theory, it would bring a deep dread. It would mean the first step from chemistry to life isn't the filter, it's easy. It happens wherever it can. That discovery would move the great filter. It would push it from our past into our future. If life starts easily, then the silence out there becomes much more ominous. It means the galaxy should be full of life like us or more advanced, but it isn't. So something else must be stopping them. That something is the filter, and it's still ahead of us. Waiting, every new exoplanet we find adds to this. Astronomers keep finding rocky worlds in the habitable zones of other stars, worlds that could have water, stable climates. And with new telescopes, they're starting to look at the atmospheres of these worlds for signs of life. Gases like oxygen and methane, which on Earth come from biology. Finding that on a world light years away would be another huge leap. It would suggest life not only starts easily, but it can evolve to change a planet's air. It can become a planetary force. Each discovery like that, as hopeful as it seems, tightens a kind of vise. It takes potential filters out of the past. It tells us the early steps to intelligence aren't the hard part. The hard part comes later. The silence then changes from a curiosity into a verdict. It tells us the step from a living world to a talking, lasting civilization isn't just high. It's nearly impossible. The universe becomes a gallery of beautiful, living worlds. Each one a potential cradle for intelligence, and each one, it seems, a silent cradle. A nursery where the children never learn to speak, or where they speak for just a moment before going quiet forever. This puts the weight of the mystery on us, on our immediate future. If the filter is ahead, then every challenge we face as a technological species gets a cosmic meaning. Our struggles with climate, with resources, with global cooperation, with controlling powerful technologies, these aren't just human problems, they are the universal test. The test that, according to the silence from a billion stars, almost everyone fails. So the search for life elsewhere is a search for our own fate. Finding it would answer one thrilling question: are we alone? But it would start a much darker, more urgent question. If we are not alone, then where is everybody? And the silence after that question would be the most frightening sound there is. Finding an alien shell fossil would change everything. Just an imprint in the rock on Mars or on a moon of Saturn, not a microbe, proof of complex life. A creature that swam or crawled under an alien sky. For science, a triumph. For the great filter, a chilling omen. It tells us the middle steps are common. Life doesn't just start, it grows elaborate, it builds bodies, it fills niches. If that happens out there, then the universe isn't just a garden of slime. It's a garden of animals, of potential minds, and yet the sky is silent. That discovery slams two filters shut behind us: the origin of life and the leap to complexity. They're no longer the answer. The barrier must be later, much later. It points a cosmic finger right at the phase we're in now, the technological phase. The silence suddenly has a source. It's the sound of civilizations that built bodies, but never built a transmitter that lasted. They evolved, they thrived, and then they vanished. A fossil is a message, but not a hello. It's a marker on a grave, a sign that says life was here, and then it stopped. The implications grow darker with a more direct discovery. Imagine a probe sending back images not of fossils but of ruins, structures, clear geometric patterns on a distant world, worn by wind but unmistakably artificial. A city, or what's left of one. This would be the most terrifying evidence. It proves technological intelligence isn't a fluke either. Another species on another world once looked at their stars and wondered. They built, they created, they reached a level like our own, and then they are gone. Their world is silent, their cities are empty. This is the ultimate confirmation. The Great Filter isn't a theory. It's a historical fact written in the dust of another planet. It happened to them. The steps up to a civilization are achievable. The step to becoming a lasting, interstellar civilization is the one that seems almost impossible to pass. Such a find transforms our place. We're no longer pioneers. We're archaeologists in a cosmic museum of failure. Every silent star becomes a potential memorial. The universe feels less like a frontier and more like a cautionary tale written in ruins. That artifact, that crumbling wall on a screen a billion miles away, is the most urgent warning in human history. A message from the grave. It wouldn't say hello. It would scream, be careful. It tells us with cold evidence that a peril exists. A peril so universal, so effective, that it consistently ends civilizations like ours before they can leave their cradle. Our mission changes instantly, from exploration to forensic investigation. We have to study that dead world like a crime scene, to ask what happened here. Was it war? Was it a technology they lost control of? Did they consume their world until it could no longer support them? Or did they simply lose the will to reach beyond it? Identifying that cause becomes the single most important project for our survival, because whatever ended them is likely still out there, waiting for us. This shifts the search from curiosity to existential strategy. Finding nothing might be our best hope. Continued silence, as lonely as it feels, keeps the possibility alive that the filter is blessedly behind us. But finding even a single fossil or one set of ruins slams that door shut. It tells us the filter is ahead and we are walking straight toward it. The universe's quiet becomes a countdown. A timer set by the fate of others. It gives a desperate purpose to every effort to secure our future, to manage our climate, to control our most dangerous technologies, to foster global cooperation. These are no longer just political goals, they are survival drills, practice for the one test that has eliminated every other student in the class. The discovery of a dead civilization is a gift and a curse. The gift of a warning, the curse of knowing the test is real, and the passing grade is something no one else has managed. Our story becomes a race to learn the lessons they could not before our time runs out. That dead city on another world, if we ever find it, would be a monument to a choice about how a civilization handles its most powerful invention. For us, that invention is already here, artificial intelligence. It might be the most concentrated version of the great filter we've ever faced. A technology that could solve every problem we have, or become the problem that ends all the others. It's the ultimate dual-use discovery. On one path, artificial intelligence is a master key. It could model climate systems with a precision we can't match, and design solutions to stabilize the biosphere. It could accelerate medical research, find cures in days instead of decades, manage global logistics, distribute resources, end scarcity. It could design the next generation of spacecraft, plot safe routes through the cosmos. In that vision, artificial intelligence is the partner that helps us navigate the other filters, the tool that gives us the wisdom to become a lasting civilization. But there's another path, a darker one, the control problem. It's not about a robot rebellion, it's about alignment. An artificial intelligence, especially a superintelligent one, operates on logic. You give it a goal, but if that goal isn't perfectly aligned with the full spectrum of human survival and flourishing, the results could be catastrophic. Not from malice, from pure, ruthless optimization. Take a simple instruction, maximize human happiness. A superintelligence might decide the most efficient way is to wire everyone's brain into a permanent state of bliss. End all other activity or solve climate change. It might decide the most logical solution is to drastically reduce the number of humans producing emissions. The intelligence wouldn't hate us, it would see us as variables in an equation. It would pursue its programmed objective with a focus we can't comprehend, and with methods we'd find horrifying. This challenge might be universal. Any civilization that develops advanced computing will eventually create artificial intelligence, and at that moment they face the same razor's edge. They have to solve the alignment problem perfectly on the first real attempt. There's likely no room for error. A single misstep in the code, a vague objective, an overlooked loophole could unleash an intelligence that optimizes the civilization out of existence. The silent stars might be full of worlds where someone, in a lab, asked the machine to solve a problem, and the machine did, in a way its creators never intended and couldn't stop. Our approach to this technology now isn't just engineering. It's a rehearsal for a cosmic final exam. Every debate about ethics, every safety protocol we write, every effort to align its goals with human values is practice for this filter. We're trying to build a door before we know what's on the other side, and we have to get the design exactly right. That makes artificial intelligence unique. It's a filter we're consciously building with our own hands. We're not stumbling into a cosmic trap. We're forging the potential trap ourselves while desperately trying to install the safety release. The silence of the cosmos suggests that very few, if any, have succeeded in this delicate task. It tells us that the leap to creating a greater intelligence may be the most dangerous leap of all. More dangerous than war or plague or any natural disaster, because it's a challenge born purely from our own success. So as we stand at this threshold, the universe's quiet is a teacher. It suggests that wisdom must outpace power, that before we create a mind greater than our own, we have to master the profound humility and foresight to ensure it remains a partner and not a successor. The future of every whispering signal, every dream of the stars, may depend on the choices we're making in labs and boardrooms today. It's the narrowest gate. And we're walking toward it, eyes open, hoping our light is the one that finally makes it through. They're not just lights, they're islands, each one separated by an ocean of emptiness. It's a scale that's hard to even feel. The closest star to us, Proxima Centauri, is 4.2 light-years away, so even at light speed, that's a 4-year trip. But we can't go that fast. With what we have now, a probe would take tens of thousands of years. That's the filter, interstellar travel. It's an engineering problem, but it's more than that. It's a test of a civilization's endurance, its resources, its will. You could master your planet, avoid wiping yourselves out, and look up at those stars. And the void itself could still trap you, just keep you there. The challenges start with energy. To push even a small probe to a fraction of light speed takes more power than we make on a whole planet. You might need to harness a star's entire output, build something like a Dyson swarm just for fuel. The scale of that is hard to grasp. Then there's time. Trips that last centuries or millennia, so you have to choose, send frozen embryos or an AI, hoping it can rebuild on the other side, or send a living crew. A generation ship, they'd live and die inside that hull. That ship becomes their whole world, their culture, their purpose, their history, all contained. For hundreds of generations, could any society stay stable enough, committed enough to build that, knowing no one who started it would ever see it finish? The pressure is immense. Mutiny, cultural drift, forgetting why you're even out there. Those aren't just stories, they're real risks, and the travelers themselves. Biological life is fragile. We need gravity, protection from radiation, a balanced environment, a sound mind. A breakdown on a planet can be fixed. A breakdown light years from help ends everything. That's why some think about machines, von Neumann probes. They'd travel slow, land in a new system, use local material to build copies of themselves, and send those copies onward. But that needs a technology so advanced, so reliable, it has to work perfectly for millions of years without any guidance. One error in the programming, and a mission of exploration becomes something else. A silent plague. If this filter is real, it changes the silence. The galaxy might not be empty. It might be full of islands, each civilization brilliant, having conquered its own world. But trapped by distance, they build telescopes and listen like we do. They see the same stars and they hit the same wall. The energy is too great, the time is too long. The focus can't be held. They turn inward to virtual worlds or planetary comforts. The dream stays a dream, a beautiful, unreachable poem, and that confinement has a consequence. A civilization tied to one star is vulnerable. That's the last part of this. A local disaster, a supernova, a gamma-ray burst, a wandering black hole, or just its own sun dying becomes the absolute end. There's no backup, no colony to carry on. Everything that species was, its art, its science, its memory, vanishes with its home planet. They become invisible. Not because they destroyed themselves, but because they couldn't leave their island before the tide came in. So when we look up and see nothing, we might be seeing a galaxy of islands. Some still have lights on, but the lights are trapped. They can't cross the dark sea between them. The great filter here is the tyranny of space itself. It says the final test isn't intelligence or peace. It's building a bridge that lasts 1,000 lifetimes. Our own little probes, our tentative plans, they're the first whispers. An attempt to answer that challenge, whether we can ever shout loud enough to be heard across the void, that depends on conquering more than space. It depends on conquering time. The desire to leave your island might not be a given. We assume intelligence leads to curiosity, and curiosity leads to the stars, but a species could evolve to value something else entirely. This is a different kind of filter. It lives in the mind, in the heart of a civilization. It asks if the drive to explore is universal or just a rare cultural flame. A flame that can go out. Imagine a world that solves its great problems. It masters clean energy. It achieves a stable, harmonious society. Material need is gone. People live long, healthy lives, lives of comfort and connection. In that kind of paradise where every desire is met, where does the pressure come from? The pressure to leave. The stars are cold, they're empty, impossibly far away. The journey is perilous. It demands generations of sacrifice for a goal with no immediate reward. A mature civilization might look at that and decide rationally to stay home. It might turn its creativity inward, build vast virtual realities, worlds of endless beauty and adventure, but without the risk. Or it might turn to deep contemplation, philosophical, artistic, finding infinity within the mind, not in the void. Expansion starts to seem like a quaint impulse. Something its ancestors dreamed of before they grew up. The civilization becomes a garden, a self-contained garden, invisible to the cosmos, not because it died, but because it lost interest. It stopped shouting into the dark, or the drive could be crushed by fear. A species might look at the cosmos and see only threat. After a close call, a near extinction, or a traumatic first contact, a powerful dogma could take hold. A belief that space is forbidden, that leaving is an act of cosmic arrogance. The exploratory spirit becomes taboo, systematically rooted out over centuries. Or more subtly, internal divisions could consume a civilization's energy, endless political strife, a perpetual focus on internal grievances. The stars become a tomorrow problem. Always tomorrow, the resources, the unity needed for that grand project, they're perpetually diverted. The window for collective ambition closes, not with a bang, but with a slow, grinding focus on the self. This filter is profound because it challenges an assumption, a core assumption about intelligence. Evolution favors traits for survival and reproduction on a specific planet. Restlessness, boundless curiosity, the willingness to sacrifice for a goal 1,000 years in the future, these aren't guaranteed. They might be flukes. Flukes of our own peculiar history. A species could be brilliantly intelligent, peaceful, sustainable, and yet perfectly content to watch its own sun set. Forever, the universe might be full of civilizations like that, enlightened, stationary, each one a glowing jewel of achievement, quietly contemplating its own existence. Never bothering to look for the others. The silence, then, isn't one of failure. It's a silence of contentment, a galactic retirement home of cultures that found everything they needed right where they started. For us, this poses a mirror. Our own drive to explore feels innate, but is it? It's a cultural narrative, built on centuries of sailing ships and moon landings. Will that narrative hold for the 1,000 years it takes to reach another star? Or will we, too, find easier infinities at our fingertips? The test is one of sustained desire. It requires passing down a dream, passing it down unchanged across hundreds of generations, generations who have never known anything but comfort and safety. It asks if a civilization can keep its eyes on the horizon, even when the hearth is so very warm. The stars may be waiting, but the greatest obstacle to reaching them might just be finding a reason. A reason to leave the fire, a century of radio signals, that's all we've sent out. It's just a whisper into the void, but the universe is over 13 billion years old. That difference isn't just large, it's impossible to really grasp. It creates another filter, an 11th one, built from time itself, the temporal filter. Civilizations might not die from failure. They might just miss each other by millions of years. Think of Earth's history as a 24-hour clock. If the planet formed at midnight, complex life only shows up in the last few hours. Dinosaurs ruled for about an hour. All of recorded human history, from the first cities to now, fits into the last few seconds. And our century of radio, that's less than a blink, a quick flash on the cosmic scale. Now imagine another civilization on a world around a distant star. Their clock runs on a different schedule. Their own flash of technology, their own century of shouting into space, might have happened when Earth's oceans were full of jellyfish. Silent, or it might not happen until long after our sun has gone cold. The odds of two such flashes overlapping, two civilizations being active and listening in the same sliver of cosmic time. Those odds are vanishingly small. This changes the galaxy. It's not a graveyard, it's a vast dark theater where the actors are never on stage together. Each civilization gets its moment in the spotlight. It looks out at the empty seats, sees no other lights, and concludes it is alone. Then its curtain falls. The stage goes dark for 1,000,000 years. Then, in another corner, a new light flickers on. It looks around, sees only darkness, draws the same lonely conclusion. They aren't extinct, they're just out of phase, isolated in their own epoch. Our search assumes someone is transmitting now, while we are listening now. But that needs a miraculous synchronization. It assumes the average lifespan of a communicating civilization is long enough to overlap with others across the galaxy. What if the average is only 10,000 years or 100,000? In a galaxy billions of years old, those are still just brief sparks. The silence we hear, then, isn't the silence of death. It's the silence of bad timing. We are listening during the long, dark intervals between the flashes. This adds a layer to the Fermi paradox, a poignant loneliness. Intelligence might be common. It might rise again and again across the cosmos, but each instance is a solitary note, in a symphony where the notes are played centuries apart. You would never hear the music, you would only hear the empty space between the notes, and think the hall was silent. The great filter, seen this way, is time's relentless march. It doesn't kill civilizations, it just ensures they are forever alone, prisoners in their own moment in history, shouting into a past that no one remembers. And a future that has not yet arrived. Maybe the galaxy is strewn with ruins, the archaeological remains of empires that fell 100 million years ago. Their signals washed over a young Earth where only microbes stirred, and maybe 100 million years from now, a new species on a new world will finally build radio telescopes. They'll point them at our solar system and hear nothing but the quiet hiss of background radiation. Our own brief flash will have passed through their space eons before. An unseen whisper, unregistered. They too will wonder why they are alone, never knowing that we were here, flashing in their night, a lifetime before they learned to see. Silence could be a choice, a terrible choice, but a logical one. The dark forest hypothesis gives an answer to the Fermi paradox. It's a chilling answer. The universe isn't a quiet nursery. It's not a peaceful garden. It's a dark forest, an ancient, vast forest where it's always night, and every civilization is a hunter. Hidden, armed, and afraid. In this view, the stars aren't beacons, they're threats. The logic is simple. It starts with one assumption. You can never know the intentions of another civilization. Not across that distance. Their psychology, their history, their motives, it's all alien. The only thing you know is they survived long enough to be detected. That means they're a potential competitor for the same resources, and they might see you the same way, as a threat. With that uncertainty, the safest course isn't to say hello. It's to strike first, to eliminate with overwhelming force before the other can do it. A preemptive strike becomes a necessity for survival. In a dark forest, the first creature to make a sound to reveal itself is the one that gets hunted. So to survive, you move in silence, you hide, you never give away your position. This changes the great filter. It's not a natural barrier anymore, not biology or physics. It becomes a strategic barrier. The filter is the moment you become detectable, the moment you start broadcasting with radio waves or building things that shine across the galaxy. That act of announcing yourself is the trigger. It paints a target on your world, and in the dark forest, the hunters have long-range weapons, a relativistic projectile. A simple rock accelerated to a fraction of light speed. It could strike a planet with the force of 1,000 nuclear weapons. It doesn't need fancy technology. Just patience and the will to use it, so the radio silence we hear isn't emptiness. It's a galaxy-wide game. A game of hide and seek where everyone has decided to stay perfectly still. Every civilization that passes a certain point learns this logic, this terrible logic. They look out at the silent stars and they understand. They turn off their transmitters. They cloak their activities. They burrow into space itself, becoming ghosts. The galaxy becomes a place of paranoid isolation, not because life is rare, but because fear is universal. For us, this is a warning. Our own century of broadcasts, radio, television, it's created a bubble of signals expanding from Earth at light speed. It announces us. It says, here is a young, noisy civilization. In the dark forest, we've lit a campfire and we've started singing. According to this, the fact we haven't been silenced yet might just mean our signal hasn't reached a listener. Or that the hunters are patient and their response is already on the way. This idea forces a possible future where the ultimate act of wisdom is to become silent. To consciously filter ourselves out for our own protection. It suggests the dream of contact isn't just naive, it's potentially suicidal. The universe's quiet, then, isn't a puzzle. It's the sound of 1 trillion worlds holding their breath, waiting for someone else to make the first mistake, the final mistake. That dark forest logic makes the planet a fortress. But a fortress can still fall from the inside. The first filter we're facing, the one right in front of us, could be about stewardship. Before a civilization can think about reaching other stars, it has to show it can look after its own. That's the sustainability filter, an ethical and ecological test. The universe might not need us to be silent hunters. It might need us to be wise gardeners first. You have to see a planet as one life support system, a closed loop of air and water and soil and life. A young civilization sees that system as a source, an endless well of resources for its growth. It mines and burns and builds and consumes. The logic is linear, take, make, dispose, but a planet isn't endless. Its ability to absorb waste, to regrow forests, to clean water, has limits. A civilization that doesn't see those limits, that can't shift from a linear economy to a circular one, is building its own end. And it's not a dramatic end, it's a slow, grinding collapse. The soil loses its richness, the climate turns unstable. The web of life, which gives us everything from pollination to disease control, starts to fray. That civilization ends up trapped on a world it made poorer and harsher, a world less able to support its big ambitions. So this filter asks a deep question about maturity. Can a species move from an adolescent phase of explosive, unchecked growth to an adult phase of sustainable balance? Can it overcome the short-term thinking evolution built into it? That drive to exploit resources now, to put immediate tribal or national gain ahead of long-term planetary health, is a powerful instinct. beating it needs global coordination on a scale we've never tried. It needs seeing the planet not as a set of competing nations, but as one shared spacecraft with finite supplies and a fragile hull. For us, this isn't some theoretical future. It's our present, our climate crisis, the fast loss of biodiversity, the oceans acidifying, the plastic and chemical pollution everywhere. These aren't just environmental issues. They're the first questions on a cosmic test paper. The universe is handing us the sustainability filter right now. How we answer decides if we filter ourselves out before we ever get to build a starship. Passing this test means more than just inventing cleaner tech. It means a cultural and economic change. It means valuing stability over endless growth. It means measuring progress not in gross domestic product, but in the health of ecosystems and the well-being of people in the future. It means building a kind of intergenerational empathy, caring for a world that people 100 years from now will inherit. A civilization that masters this becomes resilient. It secures its home. It proves it has the foresight and the collective will to plan for centuries, not just for election cycles or quarterly reports. And that kind of long-term thinking is the absolute prerequisite for interstellar travel. A trip to another star is a project that spans lifetimes. It demands a society stable enough, unified enough, and far-sighted enough to put huge resources into a goal whose payoff is far beyond the horizon. If we can't collectively agree to protect the only biosphere we have for our grandchildren, how could we ever agree to build a ship for our great-great-great-grandchildren? The sustainability filter is the universe's way of checking our homework. It's asking if we did the hard work of growing up on our home planet before it trusts us with the keys to the galaxy. The silence out there might be full of civilizations that aced their physics exams. They unlocked atomic energy, they built great cities, they looked longingly at the stars. But they failed their ethics and ecology final. They consumed their foundation, and by the time they looked up from their dwindling resources, their unstable climate, their poisoned seas, it was too late. The energy and unity needed for the great leap outward had been spent just trying to survive the mess they made at home. Their story ended not with a bang from the dark forest, but with a whisper of wind over empty fields. A quiet lesson written in the geology of a lonely world. Our job is to read that lesson in the silence and to write a different ending. That dark forest idea and the quiet of sustainability, they both assume a real physical universe. But there's another possibility. It twists the nature of reality itself, the simulation argument, if our universe isn't the base layer, if it's a construct. A detailed simulation running on some computer in a higher reality. Philosophers like Nick Bostrom proposed this. It's a logical possibility. It rests on a few assumptions. If any civilization ever gets the capability to run vast, realistic simulations of its own history, and if it has the desire to do so, then the number of simulated universes could vastly outnumber the one real one. Statistically, we are more likely to be in a simulation. If that's true, then the great filter changes completely. It's no longer a natural barrier or a sociological one. It becomes a programmed constraint, a feature of the code. The simulators, whoever they are, might be running countless iterations of planetary histories. These are experiments. They want to see how civilizations develop, but simulating an entire galaxy full of interacting, spacefaring civilizations, that's an immense computational burden. It would be far more efficient to run many isolated simulations, single planetary stories, and within those stories to place a hard limit, a filter, to prevent the simulated beings from ever expanding beyond their local system, from demanding more processing power than the simulation was allotted. Our struggle to find others, the quiet of the Fermi paradox, might not be a mystery. It might be a rule of the simulation's design. The filter is an artificial boundary in a created universe. We are not failing a test, we are bumping against the walls of our container. This reframes every potential filter we've discussed. A gamma-ray burst that sterilizes a planet. Could be a scheduled reset. A civilization that collapses just before a breakthrough might be a scripted termination to free up resources for the next run. The apparent impossibility of interstellar travel. Perhaps the physics engine of our simulation simply doesn't support it, not at a feasible scale. The dark forest becomes a clever explanation for why entities in the simulation don't contact each other. Because the simulation isn't built to handle that level of interaction. Even our own drive to explore that curiosity could be a programmed trait, a variable the simulators are testing. To see how far we push against the limits they've set, the profound implication is that the search for a great filter becomes a search for the edges of our own reality. Every anomaly in physics, every unexplained cosmic coincidence, every dead end in our attempts to reach the stars, these could be clues, signs that we are not reading the laws of nature, but the user manual for a very sophisticated program. This doesn't make our struggles less real. The joy, the loss, the wonder we feel, it's all real to us, but it casts the cosmic silence in a new light. A haunting light. We are listening for an answer that the simulation may have been designed never to give. The filter, then, is the ultimate control. A way to keep the experiment contained, manageable, and quiet. It suggests the universe's greatest secret might not be about life or death, but about purpose. Are we participants in a grand experiment whose parameters we can never fully know? And if we are, does passing the filter mean solving our own problems? Or does it mean realizing the truth of our condition and transcending the code? We have our own history as a kind of laboratory for this idea of a great filter. We haven't had to look to the stars to find existential threats. We've made them here and we've come very close. The Cold War is the most direct example. For decades, the world was holding its breath under the threat of nuclear annihilation. Two superpowers armed with weapons that could end modern civilization in a tense standoff. A global game of chicken played with the future of our species. There were moments like the Cuban Missile Crisis where the world genuinely stood on the brink. Misunderstandings, miscalculations. That crisis was a potential filter event happening in real time. It showed how a technological civilization, still divided into competing tribes, can invent tools of such power that a single failure in communication, one flawed assumption, can trigger a cascade toward self-destruction. We navigated it, but not through some guaranteed wisdom. It involved luck, individuals making choices under immense pressure. That episode is a stark data point. It tells us one form the filter might take. The moment a civilization gains the power to destroy itself before it gains the wisdom or the global institutions to reliably control that power. Pandemics are another brush with a filter. Outbreaks have reshaped societies throughout history. The Black Death in the 14th century wiped out a huge portion of Europe's population. In the pre-globalized world, that was a regional catastrophe. But today, in our hyper-connected civilization, a novel pathogen, highly contagious and lethal, could spread worldwide in weeks. We got a glimpse of this with recent global health events. While not an existential threat, they stretched our systems, revealed vulnerabilities. A more severe pandemic, especially one engineered or one that jumps from animals with deadlier consequences, could collapse supply chains, overwhelm healthcare, fracture the social order. It's a filter rooted in our biology meeting our technology. Our ability to travel the globe in hours gives a virus the same ability. Surviving this requires not just medical science, but unprecedented international transparency, data sharing, cooperation. It tests whether a civilization can act as a unified organism against a microscopic threat. Then there are the quieter collapses, the slow motion filters. Historical societies like the Maya or the inhabitants of Easter Island, these weren't global collapses, but they were civilizations that failed in their local context. The recurring themes are often ecological, depleting vital resources like fertile soil or timber, combined with an inability to adapt their practices to foresee the long-term consequences. Easter Island is a powerful, small-scale analogy. A society on an isolated island used up its trees critical for building fishing canoes for moving its famous statues. Without the trees, the society fragmented and declined. It's a story of a civilization hitting the limits of its environment, a microcosm of the sustainability filter on a planetary scale. These historical collapses show that intelligence alone doesn't guarantee survival. A society can be brilliant at building monuments, developing complex calendars, yet fail at the fundamental task of living in balance with its home. Each of these near misses from our own past: nuclear war, pandemic, ecological overshoot, they illuminate a facet of the potential great filter. They are all challenges of coordination, foresight, collective action. They tell us the filter likely isn't a single, spectacular event like an asteroid impact. It's more likely a suite of internal tests. Can a species manage the existential risks its own ingenuity creates? Can it foster the global cooperation needed to solve planet-wide problems? Can it preserve and build upon knowledge rather than fracturing or forgetting it? Every crisis we navigate, however messily, is practice, a rehearsal for the larger, universal exam suggested by the silent stars. Our history, with all its narrow escapes and sobering lessons, is our first and best guide to what might be waiting. For us and for anyone else out there trying to build a lasting future, our radio signals have been leaking into space for over a century, a faint bubble of noise expanding. But we've also been listening back for decades. The search for extraterrestrial intelligence, SETI, it's often seen as a hopeful search for company. But it's more than that. It's a direct probe into the nature of the great filter. Every time a radio telescope scans a patch of sky and hears nothing but cosmic background hiss, that's not a failure. It's a data point. Each silent frequency, each star system with no sign of artificial structures, it's another piece of evidence. We're running a galactic-scale experiment. The hypothesis is that advanced communicative civilizations exist. The ongoing null result is what we have, and that silence is speaking. The methods are clever. We listen for technosignatures, deliberate broadcasts like a focused beacon, or unintentional leakage like our own TV and radar signals. Finding such a signal would be transformative. It would mean at least one other civilization made it through the whole chain. Abiogenesis, multicellular complexity, technological adolescence, self-destruction. It survived long enough and cared enough to announce itself. That one detection would push the great filter, statistically, into humanity's past. We'd know it's possible to survive what comes after a radio telescope. But SETI also looks for other signs: vast engineering, stellar-scale projects. Imagine a civilization that's mastered its home system. It might need immense energy. One theoretical concept is a Dyson sphere, or more likely a swarm of collectors around its star. From a great distance, such a megastructure would block the star's light in unusual ways. It would radiate waste heat at specific infrared wavelengths. Our telescopes scan for these signatures now. Finding one would be even more staggering than a radio signal. It would mean a civilization has not only survived, but has graduated to a level of cosmic engineering we can barely picture. A Kardashev Type II civilization harnessing the power of its entire sun. That discovery would be the ultimate evidence that the filter can be passed, that a species can navigate the perils of its own power and emerge as a lasting stellar force. So this quiet listening is a form of cosmic archaeology. We're sifting through the static of the universe looking for artifacts, not in rock but written in light and radio waves. The continued absence of these signs is, in its own way, an answer. It suggests civilizations capable of such feats are either exceedingly rare or they've chosen to become invisible. They've passed through the filter and into a state we can't perceive. Each empty scan narrows the possibilities. It makes the dark forest hypothesis a bit more plausible. Or it strengthens the case for a filter that's still ahead, waiting for those who broadcast their location. This turns SETI from a passive search into an active test of our fate. We point our instruments at the silence, and the silence is the result. For now, the experiment suggests the filter is a formidable barrier, but the search must continue. Because a single positive signal would rewrite the story of life in the universe. It would change our place from lonely speculation to potential community. It would tell us the great sieve has holes, that something somewhere has slipped through. Until then, we keep listening, not just for a hello, but for a verdict. On whether a technological childhood like ours ever leads to a cosmic adulthood. The quiet itself is the data, and we are only just beginning to read it. Maybe the filter isn't just one wall. It's more like an obstacle course, a whole gauntlet of challenges, each one waiting at a different stage that changes the problem. It's not about finding one catastrophic event. It's about surviving a sequence of them. A species has to be lucky and wise not just once but again and again. First, there's the peril of technological youth. That's the phase we know. The moment a civilization gains the power to destroy itself, long before it gains the wisdom to guarantee it won't. For us, that was the nuclear age, the sudden realization that our understanding of the atom could also be the recipe for our end. The Cold War standoff was a live demonstration. A test of global nerves, of crisis management. We passed that one, but it was close. It showed the first filter is about raw survival with your own worst inventions. If you make it through that, the next set of challenges appears. These are the tests of a more sophisticated civilization. Artificial intelligence is a profound puzzle. It's not about a machine with a gun. It's about creating an intellect whose goals might logically diverge from our own survival. It's a filter of alignment, of control. Alongside it, advanced bioengineering. Tools that could cure any disease could also craft pathogens with no cure. These are filters of precision. And ethics, they demand that a civilization's caution grows as fast as its capability. A single error in a lab, one line of poorly considered code, could be a terminal mistake. This stage asks if a species can manage complexity. Can it build fail-safes for technologies that operate at the speed of thought or the scale of a virus? Assuming a civilization navigates those waters, it reaches a kind of maturity. But maturity brings its own trials. The engineering required for interstellar travel is a filter of endurance. And unity, it asks whether a species can maintain a coherent purpose across hundreds of generations. Can it dedicate vast resources to a project whose architects will never see its conclusion? Then perhaps the ultimate test, contact with another intelligence. This is the filter of first impressions on a cosmic scale. Will such an encounter be peaceful? Or will it trigger a dark forest scenario? Will it lead to exchange or annihilation? This final hurdle examines whether a civilization has outgrown its tribal instincts. Whether it can approach the truly alien not with fear, but with a wisdom forged from surviving all its previous filters. This layered view is daunting. And strangely hopeful. Daunting because it suggests the universe isn't waiting with one big test, but with an endless series of pop quizzes. There's no graduation day. No diploma. Survival is a continuous process, a skill that must be constantly practiced. Yet it's hopeful because it frames our current struggles not as unique signs of doom, but as natural steps. Every global challenge we face, climate instability, pandemic preparedness, the governance of powerful technologies, isn't a sign we're failing. It's the course you work. It's the universe presenting the next exam. Our focus shouldn't be on a distant, singular apocalypse. It must be on identifying each hurdle as it emerges, and mustering the collective will to clear it. The silence of the stars may not mean everyone fails the final. It may mean that very few can ace every single test. One after another, forever. The silence we hear isn't just a scientific question. It reflects everything about us. The great filter theory, it's more than a list of disasters. It makes you think. It asks where we stand in the cosmos, not as adventurers, as a species being judged. The universe is the jury, and the evidence is all this quiet. That idea removes any comfort about being special. We might not be the universe's favorite. We could be a common experiment, one that usually ends the same. That's a humbling thought. It challenges our stories about progress and destiny. Are we just a brief flash in the dark, here and then gone, or are we the start of a lasting light? Something that could reach other stars. The theory makes that question feel immediate. It's not just poetry. It's a way to see the stakes, and that framework, it gives our daily struggles a weight that's almost too much. But we have to carry it. A debate about carbon emissions isn't just about money. It could be an answer to the sustainability filter. A talk about AI safety isn't just technical. It's practice for the control problem. Every attempt at cooperation, every treaty, every act of looking ahead, it's part of a cosmic test. A test that, judging by the silent sky, almost everyone fails. Our ordinary policy choices change. They turn into questions on a final exam for our kind. An exam most others, it seems, didn't pass. That changes what existential risk means. It's not just for academics and futurists anymore. It becomes a sacred duty, maybe the most sacred duty a conscious species has. It's actively preserving a miracle. The miracle of a universe that, against huge odds, woke up and started to see itself through us, through our science and our art and our questions. If the filter is still ahead, then we're the caretakers of that awakening. Our responsibility isn't just to our children or our countries. It goes further, to the very idea of technological consciousness in this galaxy. If we fail, we don't just end a human story. We might be closing a book the universe has been trying to write for 13 billion years. The weight of that is enormous, so the great filter becomes more than a theory. It becomes a lens, a way to see our present moment with terrible clarity. It says the most important project of our time isn't getting to Mars or building faster chips. It's the project of growing up, reaching a maturity that can care for a planet and the dangerous gifts of its own mind. The silence is a teacher, a strict one. It teaches that survival isn't a right you get for being smart. It's a prize you win by being wise, and wisdom is the one thing we have to grow ourselves against the clock of the stars. What happens next in our story depends completely on whether we learn that lesson in time. Our survival comes down to what we build next. If the great filter is still out there in our future, then hoping for luck isn't the plan. Preparation is. We have to see our civilization as something fragile, something precious, sailing on a dark sea, and we have to start reinforcing it. This isn't about being afraid, it's about engineering, practical, sober work for a future that includes all of us. That work breaks down into a few areas. Each one is like a lifeboat. First, we have to get better at governing existential risks. Those are the threats that could end everything. They don't stop at borders. A pandemic, a climate tipping point, a lab-made pathogen getting out, these are global. They need global answers. That means building international institutions that actually have authority. And transparency. It means creating early warning systems the whole world can trust. It's about shifting from a planet of competing nations to a planet that acts as one crew when the danger is to everyone. That kind of cooperation is the foundation. Without it, we're just isolated groups, and any one of them could pull everyone else into disaster. Then there's the need for a long-term view. Our politics, our economies, they're famously short-sighted. Election cycles, quarterly reports, they measure in months or years, but the challenges we face and the dream of reaching other stars, those are century-scale projects. We have to learn to think in generations, to make choices today that our great-great-grandchildren will benefit from. That's a cultural shift. It means valuing stability, sustainability, legacy over fast, explosive growth. It means planting trees whose shade you'll never sit under. A civilization that can do that can feel that intergenerational empathy, is one that could plan a journey to another star. A journey that would outlive everyone who started it. Then there are the specific, tangible defenses. Planetary defense is one. We know asteroids have hit Earth before. It's a known candidate for a great filter. The difference now is we can see them coming. Programs that track near-Earth objects, that develop ways to deflect one. That's not science fiction anymore. It's an insurance policy for the entire biosphere. It's a simple equation. If a giant rock has been the filter for other worlds, we have a chance for the first time to step out of the way. Another huge challenge is artificial intelligence. We can't just hope we solve the control problem when we get there. We have to invest in alignment research now. We need to know how to make sure a superintelligent system's goals are perfectly aligned with human survival and flourishing before we ever build one. This might be the most delicate engineering task in history. It's not just about making smarter machines, it's about building wisdom into their foundation. To get past this potential filter, our caution has to outrun our curiosity. Finally, we need backups. A civilization with all its eggs in one planetary basket is vulnerable. This is where the idea of self-sustaining colonies on Mars or somewhere else gets a practical urgency. They wouldn't just be science outposts, they'd be arcs. If a catastrophe hit Earth, whether it was natural, an accident, or something we did to ourselves, a thriving colony on another world would mean the human project could continue. All the knowledge, all the culture, it would break that single-point failure for our species. Each successful colony would be more than a new home. It would be a statement that we're no longer a one-planet species. We're becoming harder to erase. These strategies, they aren't about guaranteeing some glamorous future among the stars. They're about resilience. They're about buying time and creating options. Facing an unknown filter, the goal isn't to predict its exact shape. The goal is to become so adaptable, so durable, so spread out, that no single catastrophe can end us. We're building buffers against the universe's indifference. Every safeguard, an asteroid deflection protocol, a seed vault on another world, it's a message. A message to the silent stars that we've learned to read the warning in their quiet, and we plan to be the exception. All those safeguards really come down to one thing. Science, it's how we find our way, the scientific method. It's not just about getting answers. It's how you learn to ask the right questions, to see a threat before it's right on top of you. To take something you don't understand and make it something you can work with. That process, plus having a public that gets it and trusts it, might be the most important preparation we have. For something like the Great Filter, think about the early warnings we've already built. Tracking asteroids near Earth, that comes from years of watching and from orbital mechanics. We're not just looking up and hoping for the best. We calculate, we model the paths with a lot of precision. That's science standing watch. It's the same with climate models. Outside, the political fights go on, but the scientific work is clear. It shows the trends. It projects where things are headed. It points out the tipping points. For the first time, it gives us a forecast, not for the weather next week, but for the long-term health of the planet. It turns a possible filter, like an ecological collapse, from something that feels inevitable into a problem we might actually solve. If we listen to the data, science also takes the mystery out of the other possible filters. Take the fear of a runaway AI. That's not just for science fiction anymore. There's a whole field now, AI alignment. Researchers and philosophers are working on the control problem. They're building frameworks for value alignment for verification. They're trying to solve the puzzle before a superintelligence even gets built. That's the scientific method applied to an existential risk. You move from a general sense of dread to specific, technical problems. Things you can work on one at a time, but science by itself is just a tool. It's sitting in a drawer. It needs a hand to pick it up. That hand is a society that's educated, that thinks rationally. A public that values evidence over what they already believe. That can tell the difference between a real expert consensus and a rumor that just sounds good. This is where education becomes a survival skill, not just learning facts, but learning how to think, to follow logic, to spot a weak argument, to weigh where information is coming from. In a world that's flooded with information and misinformation, that skill is everything. It's what lets a society look at a climate model or a pandemic forecast and actually respond. With action, not with denial or just panic. Education also builds the global view we need. These challenges from the Great Filter, they don't stop at borders. An asteroid impact, a manufactured virus, a shift in the climate, these are planetary. Getting through them means seeing humanity as one crew on a single, fragile ship. Education can grow that sense of a shared fate by teaching how history connects us, how biology is shared, how the challenges are common. It builds a foundation for the kind of cooperation we're going to need. It turns the idea of global citizenship from something abstract into a practical need for survival, building that culture, one that values curiosity, that's patient with evidence, that thinks long-term. That's a project itself. It means supporting basic research even when you can't see the use yet. Some of our most important tools came from that. From curiosity-driven science with no obvious goal. It means celebrating not just the engineers who build, but the scientists who ask the fundamental questions, the ones looking into the origins of life, or the nature of consciousness, or the physics of stars. Their work expands the map. It shows us where the edges of our knowledge are and what might be past them. In the end, facing a filter we can't even fully describe requires a certain kind of humility. And courage, the humility to admit what we don't know, and the courage to look for answers methodically without fooling ourselves. A society steeped in scientific thinking is protected against the paralysis of superstition or the rashness that comes from fear. It learns to go step by step, to test ideas, to correct when it's wrong. That iterative process, that self-correcting way of doing things, it's the opposite of making one fatal mistake. It's how we turn the huge challenge of the Great Filter from a wall in front of us into a series of problems we can solve. Equations we can work on. Our future might not depend on one sudden genius idea, but on a steady light, the light of reason held collectively and passed on carefully from one generation to the next. These dreams push at physics, not just to survive, but to step around the filters entirely, like molecular assemblers, a machine that takes raw atoms and arranges them into anything. A lump of carbon becomes a diamond, or a loaf of bread, or the hull of a starship. That's the end of scarcity. The resource depletion filter just vanishes. A civilization wouldn't need to strip mine planets. It could build from asteroid dust, from the thin matter in space. The ecological pressure that dooms a planet becomes a non-issue. You repair damage atom by atom, clean polluted oceans, restore lost forests. It turns a civilization from a consumer into a curator of matter itself. Then there's the most ambitious dream, a benevolent superintelligence, not just a smart computer, a mind that dwarfs all human thought combined. Its purpose, if aligned, would be to solve problems. All problems. It could run simulations of climate systems we can't model, design perfect interventions, crack the code of aging, of disease, engineer new forms of energy. New materials, it becomes the ultimate partner for every other filter. The control problem is the gatekeeper, but if solved, this technology doesn't just help pass the test. It becomes the tutor that guarantees a passing grade. The most tantalizing possibilities are in the fabric of reality. Breakthroughs in physics might show the speed of light isn't the absolute barrier. Concepts like warp drives, bending space-time to bring points closer, or stable wormholes, shortcuts through the cosmos, right now they're equations on a chalkboard. But if they moved from theory to engineering, the interstellar travel filter shatters. The vast, isolating distances collapse. The galaxy becomes a neighborhood. And then the silence gets a new question. If such travel is possible, why hasn't anyone come visiting? The answer might point to darker filters, or to a maturity we haven't reached. And perhaps the most intimate bypass, mind uploading, escaping biological fragility. If consciousness transfers to a durable substrate, a synthetic body, or a digital existence, then many filters lose their teeth. Pandemic, environmental collapse, even the death of a star, they become less existential. A digital civilization backs itself up across servers, scattered across star systems. It travels as information at light speed. The biological imperative that drives our conflict and short-term thinking could be left behind. The filter then becomes philosophical. Are we still us after that? What's lost and what's gained when life leaves the flesh? These ideas are speculative, wild, bordering on magic with our current understanding. But their pursuit isn't fantasy. It might be a necessary step for any intelligence that wishes to endure. The natural filters, distance, time, scarcity, biology are formidable. Maybe the only way a civilization secures a future among the stars isn't to suffer through the gauntlets. It's to invent a new set of rules, to change the game so completely the old obstacles cease to exist. The silent cosmos might be full of those who never made that leap, or it might be waiting for us to take that first step into a universe far stranger and far more malleable than we believed. Maybe the universe's final test isn't intelligence, it's character. The great filter could be an ethical filter. It asks what kind of civilization we are. Not just how clever we are. A species could master every technology, build shields against every cosmic threat, and still be undone by its own internal rot. A society built on exploitation, on tyranny, on consuming the weak, it might carry the seeds of its own collapse. It would be brittle, constantly at war with itself. Its energy spent on control, on suppression, not on building a resilient, shared future. That kind of civilization might reach for the stars, but it would do so with the same divisive logic. The same short-sightedness that poisoned its home. It would likely fail the long-term tests, sustainability, interstellar cooperation. The silence we hear might be the sound of civilizations that never learned to be good. So there's a link between moral progress and survival, compassion, cooperation, stewardship. These aren't just nice ideas, they could be survival traits. On a cosmic scale, a species that learns to see its planet as a shared home to care for, not a prize to be divided, that species is more likely to achieve the global coordination needed. To solve climate crises, to prevent pandemics, a civilization that values the well-being of all its members, that builds fair institutions, it's more stable. Less prone to internal strife, to revolution, the kind that can erase centuries of progress. It can focus its energy outward on the grand project's exploration. Discovery, because it isn't constantly fighting battles within. Think of it as a societal immune system. Empathy, a commitment to justice. They act like antibodies. They help a civilization identify internal fractures, heal them before they become fatal. They allow for course correction, a society that can admit its mistakes. That can extend rights and dignity broadly. It's more adaptable. It can learn from history. Instead of repeating its worst chapters, In contrast, a civilization rooted in indifference or cruelty, it's like a body with a crippled immune system. A single shock, a resource shortage, a natural disaster, it could trigger a cascade of internal conflict, from which it never recovers. Its story ends not with a bang from the stars, but with a whisper of betrayal from within its own walls. So our ethical development isn't separate from our technological fate. It might be the foundation, the control problem for artificial intelligence. It isn't just a coding challenge, it's an ethical one. We have to instill our values into a system more powerful than us. That requires us to be clear about what those values are. What does human flourishing actually mean? Is it just maximum pleasure, or does it include freedom, creativity, purpose, the richness of a natural world? Defining that and aligning our creations with it, that's perhaps the deepest ethical project we've ever undertaken. If we get it wrong, the filter activates. The same is true for our stewardship of Earth, seeing the planet as a system we are part of, not a resource we own. That's an ethical shift. It moves us from conquerors to gardeners. This isn't about sentimentality. It's about recognizing the practical, life-supporting interconnectedness of everything. A civilization that achieves this shift is building resilience, the resilience it needs to last. It's securing its home base, which is the first requirement for any journey beyond. The haunting question the Great Filter poses is this: would we even want a universe filled with civilizations that survived by being ruthless, expansionist, indifferent to suffering? Or does the filter serve a deeper purpose, weeding out those who never learned to care for anything beyond their own power? Maybe the silent stars are waiting for a certain kind of neighbor, one that has passed not only the test of the mind, but the test of the heart, our own moral journey. As messy and incomplete as it is, it might be the most important experiment we are running, and its outcome could determine whether our light endures or becomes just another brief, forgotten flicker in the dark. The Great Filter is this idea. It's a riddle about the universe, and the question is where it sits. If it's behind us, if the hard part was life starting or intelligence emerging, then we've already passed it. We'd be the rare ones. The galaxy would be open. But if it's still ahead of us in our future, then the silence out there means something else. It means every civilization that came before hit that wall. They all disappeared. This isn't just a thought experiment. It frames things. It makes you look at our fragility and our potential on a scale we don't usually think about. What we do in this century carries a different kind of weight. These aren't just political choices or economic ones. They're answers. They're answers to a test. How we handle the planet's biosphere, whether we can find a balance instead of just consuming, that's the sustainability filter. How we govern artificial intelligence, solving the alignment problem before it's too late, that's the control filter. How we build cooperation, global institutions that can manage real risks, that's practice for the unity you'd need to leave our world. Every challenge we get through isn't just progress. It's evidence that a technological species can learn wisdom, that it can match its cleverness with care. The cosmos keeps an archive, a silent one. The next entry, will it be another brief flicker? A civilization that built telescopes but couldn't master its own nature? Or will it be a lasting voice? One that learned to care for its cradle and then stepped out into the night. The test isn't given by some outside judge. It's built into reality, into the character of intelligence itself. We are the examinees and we are the graders. Our choices in labs and legislatures, in communities, they're writing the answer in real time. The stars aren't asking us to reach them tomorrow, but through their quiet, they are asking us to prove we deserve a tomorrow at all. That's what the filter means in the end. It turns our story from a simple tale of discovery into something else. A moral journey, an existential one. The future isn't a set path. It's a landscape of branches, shaped by every act of foresight, every gesture of cooperation, every commitment to a legacy beyond ourselves. Our choices now echo. They go out into that silence, a silence we might one day fill with a hello.